All right. Hey, everyone. Welcome, welcome, welcome. So if you're here, you are here for the ECS-cape, hijacking IAM privileges in Amazon AWS. If you guys all want to take some seats, file in wherever you can, find an empty seat if you can. Just to start out here real quick, I want to thank one of our sponsors for this presentation here. So this is for Wiz, one of our silver sponsors. You can find more information at wiz.io or talk to some of the Wiz folks out there in the lobby if you choose. And just in addition, any questions you have, feel free to either post them on Slack or at the end we'll try to take everybody's questions that we can before the break, and I'll pass the microphone around. And without further ado, please welcome Naor Haziz for ECS-cape, hijacking IAM privileges in Amazon ECS.
Hello, everyone. Can you hear me good? Yeah, hi. So, what if I told you that a single container running in your cloud environment can use an internal AWS protocol and hijack the credentials of another more powerful container running on the same instance? In some cases, that's all it takes to take over your whole cloud environment. Today, I'm going to show you exactly how can it perform using a vulnerability that I found called ECS-cape. It's a wordplay between ECS and escape because it lets ECS task escape its assigned boundaries. So, first of all, I would like to introduce myself. My name is Naor Haziz, based in Israel, and I'm a software developer and security researcher at Sweet Security. In my free time, I'm also a DJ and a huge fan of Rust programming language. After this talk, I'm going to throw a party in my room, so you're more than welcome to join me. Room 912. So let's begin. Here's a quick overview about what we are going to talk about today. First of all, we are going to have an ECS overview, what it is and how it works. Then, I'm going to share with you my personal story of how I encountered this vulnerability. Afterward, we'll have a technical deep dive about the vulnerability itself, some impact and defense techniques, and key takeaways. And of course, we'll have a live demo. So let's begin. Before we deep dive into tech, let me give you a reason to stick with me. According to a survey, a third of the developers using orchestration technologies rely on Amazon ECS. That makes it one of the most adapted orchestrators probably used in the world. That means that this talk is directly relevant to a huge portion of real-world production workloads. So let's begin. First of all, what is Amazon ECS? Amazon ECS is a native container orchestration service, essentially a simpler managed alternative to Kubernetes. It runs Docker containers on your cloud environment, and it's deeply integrated with AWS core features like IAM, logging, and networking. There are three core concepts I'll refer to throughout this talk: a cluster, a service, and a task. ECS cluster, in simple terms, is just a group of EC2s managed by Amazon ECS. This is where your containers are actually going to run. In each EC2 instance, you'll find a service and a task. A service is ECS way of saying, keep this task running for me. It handles restarts, scaling, and deployment. A task is a single running unit. It contains the containers itself, which are the actual processes doing the work, like your app, sidecar, or logger. In ECS, each task has its own unique IAM role called task role. That means that even though they are all running on the same EC2 instance, they have isolated permissions. As you can see in this slide, task 1 has one role, and task 2 has another role, and the task 3 has another role. ECS has two launch modes, Fargate and EC2. Fargate is fully serverless, just define your task, and let AWS handle the rest. In EC2 launch mode, you manage the EC2 instance yourself, which means that everything is running in your cloud environment. This talk is going to focus on the EC2 launch type because this is where the vulnerability actually works. Let's zoom in on how ECS over EC2 works. Each EC2 instance is assigned with a role called ECS instance role. This role contains permissions to pull Docker images, and send logs to CloudWatch, and many more. Essentially, it's the role that has the basic permission for ECS to function. On that instance, you'll find the Docker daemon that actually runs your containers, and a component called the ECS agent. The ECS agent acts as a bridge between the AWS control plane and the instance itself. The ECS agent authenticates to the control plane using the instance role and receive commands like start this task, start that one. This whole unit, EC2 plus ECS agent, is what AWS refers to as container instance. I know it's a confusing name, but it is what it is. You can find it, it has a unique identifier, an ARN, and you can find it in your Amazon console. Now that we got this out of the way, let's move on to the discovery story. As you know, I work at Sweet Security, and I was working on our EC2 sensor, which is the main component for detection and response. One day, my manager, Ron, came to me and asked me, can you monitor ECS tasks? My initial response was, yeah, why not? Let's try. I thought to myself, as I mentioned earlier, the ECS agent is communicating with the Docker daemon, so I can do the same and get the data about the tasks themselves. Inspecting running container, I noticed that every task that's running by ECS has these labels, which contains all of the information that I needed for the task, like the cluster, cluster name, task ARN. But one thing was missing, the service name. I really wanted to know the service name of the task, and this information is nowhere to find. This is a sad picture of me used from ChatGPT. So I started digging online, and I found this endpoint called ECS Task Metadata Endpoint version 4. It's a unique endpoint that the ECS agent exposes to each task running on the instance. It returns tons of useful information, like the task ARN, revision, and family, but most importantly, it returned the service name, which I really wanted. So here's where things got interesting. I thought to myself that because the ECS agent has the service name, it returns it using the metadata endpoint that I showed you before, I can do the same logic and get it myself. I assumed that the instance role has permission to list the services. So I went to AWS console, and surprisingly, I found out that it's missing the list services permission. So how was the ECS agent receiving that info? The first thing I did was to set up a proxy server and watch the ECS agent traffic. I saw that it's connecting to a WebSocket called ECSA. This is the ECS service. And I noticed something really weird. It was passing a query parameter called send credentials equals true. That immediately made me suspicious. Here's a real message that I captured from the WebSocket showing a real role credentials over the WebSocket itself. So I had a thought, can I impersonate the ECS agent? If I'll be able to trick Amazon control plane into thinking that I'm the agent, can I get those tokens too? So I went to my boss again, Ron, and I showed him what I found, and I told him, look, this is really interesting. Please let me research it. And Ron, being Ron, nodded and told me, you've got 3 days, and this is where the hunt began. I'm so sorry, Ron, I have to share this meme. Now we'll deep dive into the technical aspect of the vulnerability itself. First, I wanted to point out that the ECS agent is completely open source. I encourage you to go on GitHub and find it. It's really interesting. It was really helpful for me in my research. And if you search for it and have some interesting finds or questions, feel free to reach out. I'd love to hear from you. So let's start with a quick look on the ECS instance role itself. It contains 2 specific permissions, discover poll endpoint and ECS poll. These permissions are crucial to the way that ECS works, so keep them in mind. Now I'm going to show you how the ECS agent itself authenticates to the AWS control plane. The first thing it does is using the instance role, specifically the discover poll endpoint permission that I mentioned earlier. it calls an API called, surprisingly, Discover Poll Endpoint. This API returned back a specific URL. I searched online for this specific API, and I found this AWS documentation stating that it should not be used outside of the ECS agent, which of course only made me more interested. I really wanted to know what's going on in there. Here's an example of how the returned URL look like. I'll refer to it as poll URL. It contains the region and Amazon AWS.com and some weird number that I'm going to cover later. This is a snippet from the ECS agent code itself, and this is where the magic happens. It takes the returned URL and constructs using it a WebSocket request. It actually, what it does, it's taking the URL and construct the WebSocket with a bunch of identifiers about the agent, like the agent version, cluster ARN, and the container instance ARN. But most importantly, the send credentials true flag. So, how the agent authorization works. I'll start with explaining what is SigVi4. SigVi4, it's an algorithm used by AWS, and this is AWS ensures that the request really comes from a valid credentials. It takes the user role and the request data, sign it using a cryptographic algorithm, and create a request signature. Then AWS control plane can validate that signature and see if the user has sufficient permissions. So in this example, if I wanted to access the S3 bucket or the DynamoDB, I really have the permission, and it's all fine. Now let's move on to the ECS agent itself and how it works. It takes the instance role that I showed you before, and the WebSocket URL it constructed. Then it signed it using SigVi4. And AWS process it and check one thing. That it has the ECS poll permission. This is why this permission is so crucial. This is the only permission needed to authenticate to the ECS service itself and to connect to the WebSocket. So let's summarize this flow. The ECS agent using the instance role again and get the poll permission. Then it signs it using SigVi4 and connect to the WebSocket. Then it receives back all of the ECS task roles in the same instance. It receives all of the credentials of the running roles, of the running tasks. Now, what's going on over that WebSocket? The communication is happening using a protocol called ACS, which stands for Agent Communication Service. It's a WebSocket internal protocol used by the ECS agent to communicate with AWS. It's not documented, but we know it carries messages like task metadata. This is where the service name that I've been searching for, it's in the task metadata. Agent level directives, so like configuration updates and more. And most importantly, the IAM credentials for all of the running tasks in the same container instance. So to summarize the authentication flow, first of all, we use the Discover Poll Endpoint permission and call the Discover Poll Endpoint API. We receive the URL. Then the ECS agent constructs the WebSocket request using a bunch of identifiers. Afterwards, it signs it using SigVi4. And lastly, it connects to ECS and receives all of the role credentials. So now here's the real question. Can a task impersonate the ECS agent? Let's find out. The first thing we need is the poll endpoint URL, but we don't have the Discover Poll Endpoint permission. What can we do? Remember the URL that I showed you before? So it has a unique structure. All of the things are essentially the same. The only thing that changes is the region and the backend server. The region we know, so we can use it. And for the backend server, we can just brute force and find out. So this is what I thought, and this is why I tried. Now that I have the URL, I try to use my role, sign it, and connect to AWS. But sadly, I don't have the ECS permissions. So what can I do? This is where I had an idea. I can use something called IMDS, which stands for Instance Metadata Service. It's a unique HTTP endpoint that's available in every EC2 instance. It returns data about the instance itself, like the region, instance ID, and private IP address. And most importantly, it returns the instance role credentials. In ECS, IMDS is enabled by default, and each running task on the instance can access it, which means that from each task, I can use IMDS and get the credentials for the ECS instance role, the same one used by the ECS agent. Using this technique, I can use IMDS, get the discover poll endpoint permission, and get back the poll URL. Then, I need to construct the WebSocket URL. But I have a problem. Where do I get this identifier? So I tried a lot of stuff, which I'm going to share with you now. Most of the identifiers I could get using IMDS and the task metadata endpoint version 4 that I mentioned earlier. But one thing was missing, the container instance ARN. It was a real headache. Here's me said again. The first thing I tried is look at the instance role, and I hoped that it has the permission to list the container instances. But sadly, it hadn't. So I looked at the ECS agent, and I found that it's getting the instance ARN, container instance ARN, and writing it into a Bolt DB on the EC2 machine. ECS has a feature to create a volume and mount point. So I thought to myself, I can create a mount point to the host root and get the Bolt DB, and from there, I can get the instance ARN. But it wasn't enough. This is a unique configuration that makes the vulnerability depend on it, and it's not very common, so it's useless for me. Then I went to the instance role again, and I looked at these two permissions, register and deregister container instance. These are the permissions that used to register the container instance itself by the Amazon ECS agent. So I thought to myself, maybe I can register myself as a new container instance. But it had a problem, because then I received back tasks that should be for another container instance, not the same one as mine, and I should be able to execute them. So I essentially break ECS because I can't execute a task. I don't have the permission to talk to Docker daemon. The other thing I thought is doing this and then deregister the ECS agent itself. But again, it's break the ECS, and I thought that I can get back the roles. But again, it stopped the execution of other tasks, which I don't want. This is where I got lucky. Inspecting the ECS agent, I noticed it has another unique endpoint called container introspection. This is a unique endpoint that it exposes to each running task on the instance, and luckily, it returns the cluster, the container instance ARN, and even the agent version and hash. All of those I need to construct the WebSocket URL. This is me being happy. So now what? Because we have IMDS, we can use IMDS and get the poll endpoint, ECS poll permission. Then, using the agent introspection, we can get the needed identifiers, construct the WebSocket URL, and sign it using SigV4. Later, we can authenticate to the control plane and receive back the task credentials for all of the running tasks on the same instance. So to summarize this flow, what we are doing in ECS-cape. First thing, we use the IMDS and get the EC2 instance credentials. Then, we get the poll endpoint using discover poll endpoint API. Afterwards, using container introspection API, we get the needed identifiers to construct the WebSocket URL. Then, we sign it using SigV4 with the ECS poll permission, and lastly, connect to the ECS service. Then we receive back all of the task credentials. I showed it to my boss, and he was very happy, said it's a great success. What AWS documentation have to say about it? So I searched online, and I found this documentation stating that a container never has access to credentials that are intended for another container that belongs to another task. That's the promise of task roles: isolation, security, and separation. But as we saw, using this technique, we can reach beyond that boundary. What is the impact? So let's say I have a task, and I really want to access a MongoDB. But sadly, when I use the AWS Secret Manager, I do not have the permission to get the secret for the MongoDB. Now, and this makes me sad again. Now let's assume that I have another coexisting task in the same instance with the permission to get secret value. It can use its role, get the MongoDB secret, and authenticate to the MongoDB. Now, what can I do? Using the technique that I showed you before, I can get the other task permissions and authenticate to the secret manager. I'll receive back the Mongo access URL secret and connect to Mongo and access MongoDB, which I haven't had the permission to access before. Okay, another thing to mention is that the agent impersonation goes beyond just task credentials. It also exposes metadata about the instance itself and other tasks running. So it's leaking data which were previously out of reach for me. To summarize the impact, we have cross-task IAM role hijacking. It's a clear privilege escalation path. We can steal the role credentials of any other task running on that instance. Second, we have the agent impersonation via internal protocol. The agent returned the ACS protocol, leaking data about other tasks and the instance itself. Lastly, it requires no misconfiguration. IMDS is enabled by default for ECS, and the ECS instance role has the permission that I mentioned before by default. Now I'm going to share with you a quick demo. Oh, you can't see my screen. Just a sec. Okay, great. So, I created a cluster called ECS-cape, and it has two unique, oh, I can see it from here, that's great. It has two running tasks inside of it, Hypriv and ECS-cape. Let's inspect the Hypriv. Hypriv has this task role, ECS-cape administrator, that has only one policy. It has administrator access. It means that it has the permission to access everything in my cloud environment. Now, the other task that I use, called ECS-cape, and the ECS-cape has the ECS-cape role. This role contains one policy as well, which stands for deny everything. It means that basically I can't do anything in your cloud environment. Now, I created an S3 bucket and called it forward cloudsec 25. Now let's go to the instance itself. Great. Let's start being sudo, and then let's do Docker PS. We'll see that the running containers are the ECS-cape task, the Hypriv task, and of course the ECS agent itself. Let's use Docker exec IT and execute ourselves in the ECS task. Wait, why am I so that? Docker exec. Sorry, I haven't been. Great. These tasks contain one binary called ECScape. This is a command line tool that I wrote that implements the ECScape technique itself and try to use and try to delete an S bucket, an S3 bucket. So let's run it with help, and we'll see that we need to supply the S bucket 3 name. So let's use the forward cloudsec 25 and see what's going on. Wait. As you can see, it prints out the full credentials for the other tasks, and it states that the S3 was successfully deleted. Now, if we go to the S3 page again, you can see that if I refresh it, it no longer exists. So this is the real impact of the vulnerability itself. So let's move back. Thank you. Thank you very much. Oh. There's options. Excuse me? You can see it? Oh, yeah. Okay, let's move on. So I had a recorder demo, but we are not going to see it. It was an extra if I failed. So the tool that I showed you, called ECS-cape, is available on GitHub. It's completely open source. I encourage you to go and check it out. Here's a barcode, you can find it. If you want to collaborate, talk with me about it, feel free. I'm more than available to it. And of course, I wrote it in Rust because, well, I love Rust. So sorry for those of you who doesn't like this language. So what are the mitigation techniques? The first thing you should do is to disable IMDS access to the task itself. If you disable IMDS access to the task, then the task won't be able to get the instance role, and therefore won't have the poll and discover poll endpoint permissions. Keep in mind to never disable IMDS to the instance itself. Because if you will, the ECS agent won't be accessible to it, and ECS itself will break. AWS has a great documentation about how you can disable the IMDS access for specific tasks. It depends on the network mode they have, and you can find it online. You can take a picture of it now, or if you want, you can search it online later. Another thing is to never grant a task the discover poll endpoint permission, because if it has those permissions, then it can do the same technique without using IMDS and without the instance metadata service. Same goes for ECS wildcard, because it contains those permissions. And please do me a favor, never give this permission to a task. It can be hijacked, and in general, it's a bad practice. So to summarize the best practices, first of all, separate high and low privilege task. Sensitive services should never run near risky tasks on the same instance. Second of all, isolate tenants in multi-tenant systems. If you are happening to implement a multi-tenant system in your code, never give them never share the same cluster, because the role can be hijacked, or at least separate the instances that they are running on. And lastly, minimize task role permission. Don't give a task a permission that it doesn't need. Just give it the needed permissions. So, to summarize this talk, what was going on? I went to AWS, and I sent a mail about the vulnerability itself. AWS says that it's not present a security concern for AWS. This was their final ruling. And another thing that they say, that they are going to update public documentation and consider long-term defense and in-depth changes, which mean that we are safe. This is the documentation that they had before, as I showed you. And now, the new permissions are that tasks running on the same EC2 instance may potentially access the credentials belonging to other tasks on that instance. That's good. This is what I think going on in their office. About the acknowledgement, I was talking with AWS, and again, they said that they are going to change the documentation and give me a public recognition about it in their documentation changelog. Also, they say that they are going to draft a statement of appreciation for me, which is nice. I get the appreciation that I needed. So to summarize this whole talk, on EC2, task and the ECS agent share one trust boundary, okay? Any task can use the discover poll endpoint and poll permission to impersonate the ECS agent and hijack roles on the same instance or leak data that it wasn't been able before. If there's one thing I want you to take you from this from this talk, is please, task level hardening is essential. AWS is not going to change the behavior that I show you for now. So one thing you should know is that IAM roles is your last line of defense. Please, disable IMDS and don't give task roles they don't need. Keep that in mind. And don't take my words for it. Here's a clear declaration from AWS during our emailing, showing that hundreds of millions tasks worldwide is accessible to this vulnerability. So yeah, it's not just another edge case, it's something that can affect each and every one of you. After I sent them this presentation, they had a feedback, so I want to show it for you, saying that Fargate has already has a better blocking defaults, and Fargate is not vulnerable for this exploit. So I think they try to encourage you to use Fargate, and this is the feedback that I got. That's it for me. Thank you, everybody, for being here today. This is actually my first time speaking on a conference, so thank you very much. Here are my details. You can find them. This is my LinkedIn profile. We have a QR code that you can scan it, and I'm happy to take questions. Thank you.
Awesome. All right, well, we'll kick some questions off. I've got one on Slack that we'll start with here. So since you used IMDS as an initial access to get the credentials, would anything have changed if they were using IMDS v2 or just increased difficulty?
No, it does not affect anything. I can get the IMDS v2 token and use that. It's the same thing.
All right. Okay, so let me give you some questions for the room. I see one over here to start.
Did AWS ever mention why a task needs access to IAM?
Can you talk to the microphone?
Sorry.
I can't hear you.
Did AWS ever mention why a task ever needs access to the EC2 IMDS? Like it seems like it should just be blocked by default.
This is what I thought, but I think they can change it because maybe people rely on it. So if they are going to disable it by default now and on, they are going to break some applications. The usage of IMDS is pretty obvious. Like you can get the ARN of the instance, region. You can know in which environment you are running. So I think that's the reason.
But since each ECS task has its own IAM role, you would think they can do that without.
Yes, I completely agree with you. It is what it is.
All right. More questions. I got some way in the back here. We'll go back here.
Hey, so for the role, like, does it still assert the principal, like who assumes the role? Like, let's say if there's a like default deny unless the principal is ECS task ABC, like, would that mitigate this or no?
Like, I'm trying to understand the question. Can you
like,
clarify?
Let's say we have two roles, right?
Okay.
One is ABC, one is, I don't know, CDE.
Okay.
And then both of them have a default deny, but like, with an exception of one task principal that has access to assume, like one task can assume one role, the other task can assume the other role. Like, would this vulnerability still work, or would the deny on the IAM policy prevent it?
Like if I'm not understanding the question, I'm sorry.
Okay, so let me, I guess, rephrase. So for a policy, when you showed the policy with a star, right? You can put a condition in and say you can deny all assume role events unless it's a certain principle. So I guess what I'm trying to ask is, does it still analyze who the principal is assuming the role? Like if the task ABC is trying to assume the role of CDE, and the CDE has the block in place that only task CDE can assume it, like would that, is that verification bypassed, or is that sufficient to stop?
Yeah, I think it bypassed. I haven't checked it like in specifically that you are saying, but because the task credentials are over the ACS protocol itself, I get the credentials themselves and I can use it as is. So I can assume the role from whenever I want.
Gotcha. Do you mind sharing the QR to the GitHub again?
Yeah, for sure.
Thank you very much.
I would like to talk with you later if you want.
Awesome, good question. I've got another one just as I'm looking through the Slack here. Why wasn't this exploit granted a CVE? Can you detail on that?
Don't ask me, ask AWS. I asked for them a couple of times to get a CVE or some recognition, and they did gave me some. They gave me they haven't yet gave me the documentation log change credit, and also hadn't gave me the appreciation later, but they said that they are going to handle it, and I believe them. I haven't got any bounty or CVE, and this is their call.
All right. Any more questions for the room? Anybody once, twice? No? All right. Well, if there's any more questions for afterwards, please do feel free to stick around and ask for Naor. And then other than that, just give a round of applause, please, for Naor.